The purpose of this video is to describe some practical applications of the equals PMT function, or payment function. This model will utilize this function. We will be covering some of the built-in business functions for the remainder of the semester. One of the most practical features of the Excel program, or any other spreadsheet program, is its ability to quickly calculate loan payments under various and differing assumptions. The equals PMT, or payment function, could be a very useful feature for you as you enter into more and more financial transactions as you get older. The equals PMT function automatically calculates the periodic payment of a loan based on the loan amount, the interest rate, and the term or period of time over which the loan will be paid. The format for the equals PMT function is equals PMT followed by 3 variables in a specific order. The 3 variables are the rate, the number of payments, and the loan balance or principal. All 3 of these components must be entered in this exact order. In addition, commas separate the 3 components. It's important for you to remember that the interest rate and the number of payments should always be in the same time denomination. Interest rates are usually expressed in annual terms. This means that if you are making monthly payments, then both the rate and the number of payments should be expressed in monthly terms. Let's look at an easy example. For example, if you are borrowing $12,000 and have an annual interest rate of 12%, and you are making payments over 4 years, then the monthly interest rate would be 12% divided by 12, or 1% monthly, and the number of monthly payments would be 48, or 4 years times 12 months in a year. Think about this. How would this formula be phrased using Excel syntax? This is how it would be phrased. Again, the equals PMT function requires 3 variables separated by commas. The first variable is the interest rate, the second variable is the number of payments, and the third variable is the loan balance, and these items must be cell referenced. In other words, I don't want to see any numbers with the exception of the number 12 in your answer section. Everything should be cell referenced to your data section. Let's take an example, or let's take a look at an example. So here's an example of an Excel spreadsheet where the loan amount is given as $12,000. That is also known as the principal amount. The interest rate is 12% annually, and the term of the loan is for 4 years. Using the equals payment function, we can input the 3 variables in the correct order, and the computer will quickly calculate a loan payment. So here we go. Equals PMT. The first variable is the interest rate expressed in the same term as the payments. Since we're making monthly payments, as most of you do on your car loans, we need to take this 12%, which is an annual rate, and turn it into a monthly rate. So I would divide by 12. That's the first variable, is the interest. The second variable is the time factor. How many payments are you making? In this case, we're making a 4-year loan, which would equate to 48 payments. So we will take that 12 and we'll take the 4 and multiply it by 12 monthly payments per year. That'll equate to a total of 48 payments. And finally, the last variable is the loan balance. I want you to notice that everything in my formula here is cell referenced. There are no numbers except for the fact that there will always be 12 months in a year, so that's not a problem. When I press the Enter key, Excel will compute the amount of that specific loan payment. We press Enter. Our payment, monthly payment, would be $316.01. I want you to notice something. The equals payment function returns a negative number. Sometimes negative numbers are difficult to work with in accounting, so we're going to teach you one additional feature called the absolute function. The absolute function will turn the number positive. So I'm going to adjust my equals PMT number up here by typing ABS. So let's get this cursor up here. I'm going to put ABS at the start, and then I'll go to the end of the formula and put the ending parentheses, and when I press Enter, it turns my payment from negative into a positive number. The beauty of this is if you cell reference all of the variables, you can hopefully see my formula up here. If everything's cell referenced, you can change any one of these numbers and your payment will automatically recompute. For example, if you decided that maybe that payment was too much and you wanted to change the term of the loan from 4 years to 5 years, all you have to do is change one number, and if you've cell referenced everything, as soon as I press Enter, my new payment is automatically computed. Same thing with the interest rate. If the interest rate changed, maybe you could get a 7% interest rate. All the user has to do is change the interest rate here, press Enter, and the payment is automatically computed. I believe this will be one of the most practical templates that we will create this semester, and hopefully you will find that you can use it many times throughout your personal financial lives. So now let's expand this problem to a bigger financial decision, which is buying a house. In this problem, we will be calculating loan payments for different houses under a variety of loan options. The major difference in purchasing a house is that there are usually points involved. Points represent fees charged by the lender for processing your loan. 1 point is equal to 1% of the loan balance, not the purchase price, which most of the business world believes, but the actual loan balance, the amount you borrow to finance your house. So on a $50,000 loan, 1 point would be equivalent to $500, or 1% of $50,000. 2 points would be equal to $1,000, or 2% times $50,000. With the prices of homes in California and the high loans required to purchase them, points will really add up. So let's read through your assignment, which you should have a copy of in your hand. It says, Mr. O.B. Servant or Observant is looking to purchase a home. He knows you have been studying accounting and he has asked you for your advice on buying a house. He has looked at many different houses and isn't sure how much the monthly payment will be based on a number of alternatives. The handout then gives you 3 choices of a home. A 2-bedroom with 1 bath that sells for $300,000, a 3-bedroom with 1 bath which sells for $350,000, and a 3-bedroom with 2 baths which sells for $400,000. He has spoken to his bank, and the bank has provided 3 potential options for financing the purchase of the house. In reality, banks will offer you sometimes between 8 and 10 options, and it's a very overwhelming decision unless you have the tools in your hand to correctly choose which payment option is best for you. So in the class example on the handout, there are 3 options. The first option is 10% down with 1 point and interest of 7.5%. The second option is 15% down with 2 points and fixed interest of 7%. And the third option is more down, in this case 20%, with 1 point and fixed interest of 7%. The term on all loans is 30%. The points must be paid up front at the time of closing. Our goal is to prepare an analysis of these alternatives showing all the data, the resulting down payment, the loan fees, and the total due at closing. In addition, you will show the monthly payments for each house. For a real eye-opener, we're going to calculate the total amount that we would have paid for the house over the life of the loan. This should allow you to easily see how much the financing costs truly are. Make sure you have the attached example to get you started. You can custom tailor this template to fit your needs. Remember that we will keep flexibility in mind at all times. In other words, the user should be able to enter any variables they wish and have the answer section calculate for them automatically. Again, this means that your answer section should only contain cell references. I hope you heard that. If you have your handout, highlight that as I read it again. Your answer section should only contain cell references. As we mentioned before, the payment function returns payments as negative values. So in order so that we can use positive numbers, we're going to use the ABS function. Also, because interest rates usually fluctuate, they can result in lots of decimal places. To keep mathematical rounding errors from happening, we will also use the equals round function. In case you've forgotten, this was introduced to you in the payroll problem. I'm going to walk you step by step through the formulas. However, you should have the loan analysis of house 3 in front of you as we do this. On the website is a suggested solution for house number 3. That would be the 3-bedroom with 2 baths, and we've included all 3 of the loan options. So let's take a look at the answer section and let's talk about the formulas. The down payment is equal to the purchase price of $400,000 times the down payment percentage of 10%. So $400,000 times 10% gives us $40,000. Remember, you're not using any numbers in the answer section. You're simply referring to the data section with the various calculations. The points paid at closing is a line item that often confuses people. Remember, as stated earlier in the lecture, the points are based on the loan balance. That means the amount of money that you're borrowing. So in option 1 circumstance, if we bought a house for $400,000 and we were paying $40,000 down, that means our loan balance is $360,000, or $400,000 minus $40,000. Since option 1 says we're paying a 1 point or 1% of the loan balance, then $360,000 times 1% is how we came up with the $3,600. In this example, we are assuming that the points will be paid up front. That gives us the best tax deduction possible. In real life, you can wrap those points into the loan instead of paying them up front, which would simply increase your loan balance. So this home buyer, if they choose option 1, would need to walk into the closing with a total of $43,600, which is just the sum of the down payment and the points. The next challenge will be calculating the monthly payment. We just covered the PMT function earlier in the lecture. Remember, the equals PMT function should be used here with the three variables in the correct order separated by commas. For example, the first variable is the interest rate, and remember, since we're making monthly house payments, you'll have to convert that interest rate from an annual rate to a monthly rate. The second variable is the term of the loan. Since this is a 30-year loan, we would be making 360 payments. Once again, do not enter 360, but rather use a cell reference to this cell times 12. And the third variable would be the loan balance. In option 1's case, that would be $360,000, or $400,000, which is the price of the house, less the down payment of $40,000. Put those three variables in, use the absolute reference function as demonstrated earlier so you get a positive number, and also consider using the equals round function at the very front of the formula with the comma 2 for 2 decimal places at the back. That will prevent any rounding errors from entering into your analysis. So we've just talked about the upper half of the answer section. So now let's take a look at the cost of the house over the lifetime of the loan. The total paid at closing, the $43,600, was computed up here, so just cell reference that cell. The loan payments, the $906,181.20, was computed by taking the monthly payment that you computed here times the number of payments over the life of the loan, in this case 360 payments. The two of those added together will be the total price of that house that you pay over the lifetime of the loan. So if the original house cost you $400,000, you subtract that from the total amount paid, and there are your financing costs. Most people are shocked to see this number, and as you can see, many times finance costs are more than the original price of the house. So to summarize, the down payment is the purchase price multiplied by the down payment percentage. You will use cell references to accomplish this. The points paid equals the loan balance multiplied by the points charged. As we demonstrated, the loan balance is the purchase price of the house less the down payment made. In our example, the $40,000 minus the $400,000 price of the house minus the $40,000 down payment. That would equate to $360,000. The total due at closing number is the sum of the down payment and the points paid at closing. Again, follow the printout from the loan site so you can calculate each item step by step. To review again, the monthly payment is made using the equals PMT function. Make sure the interest rate and the number of payments are in the same time denomination. In this case, and in most cases with installment loans, this will be in months. Once again, the formula for the equals PMT function is equals PMT with the three variables separated by commas. The interest rate is first, the number of payments is second, and the loan balance is third. Also, it's helpful to use the round function as well as the ABS function so you can adjust your formula to look like this. Okay, I would consider you tagging this slide and make sure that your formulas look similar to it. Finally, you will be computing the cost of the house over the life of the loan. The total paid at closing was computed previously. The total loan payments are equivalent to the monthly payment amount multiplied by the number of monthly payments. The sum of the total paid at closing plus the loan payments will equal the total amount paid over the life of the loan. You would compare this to the original purchase price to compute the cost of financing. I cannot overemphasize the importance of this template. As I mentioned to you once before, you will be buying high dollar value items like cars and homes over the course of your life. Banks will try to sell you the loan that makes them the most money. We want the loan options that save us the most money. So the goals are diametrically opposed to each other. That's why this template is so important. This puts the power in the hands of you, the borrower. Don't rely on the banks or credit unions to disclose these items to you. This should allow you to take any loan option and compute the total cost of the home over its life. That way you can make the best possible decision for your family. One more closing note. If you set up your template properly, then the only thing that should change between the three housing options is the price of the house, which I've highlighted and will put in yellow here. Remember that we will be considering the purchase of 3 different homes using 3 different financing options. This is the example of the answer for house number 3. Since the only difference between those 3 houses as far as the accounting is concerned is the purchase price, once you finish the template and change the price of the house, everything down below in your answer section should recompute 100% on its own based on the change made above. This is what we mean by flexibility. I've purchased quite a few cars in my lifetime and quite a few homes in my lifetime, and I'm more than happy to answer any questions you may have on this template. Again, I believe this is the most important template we will be doing all semester long in terms of personal value to you. I'm here to help. I would be happy to take a look at your templates if you send them to me in a timely manner during the week that they're due. And I look forward to reading your updates by Sunday night.